Good morning, everyone. This video is for Tuesday, December 15th. It is the start of lesson 10, which is involving multiplication and division of decimals. And I'm going to walk you through today's material, and hopefully with this video and the practice, you will have some success. It's really important this week in my absence that you are responsible and just try your best. I know it's not the same as usual with my help if you are struggling, but I just want you to use these videos to help you understand the material for this week, which we will wrap up lesson 10 before the break. So make sure you have your whiteboard. We are going to try problems later on that I want you to do and pause and then listen to my explanation. I am going to try to keep this shorter, but it is a lot of information that I want to share with you. So bear with me doing this from home. So hopefully my dogs are quiet. And we're going to be talking about tax today. And so my first question is just for you to get your brain going. And what does tax do to the price of an item when you buy it? Hopefully you are thinking about how it's increasing that price. So you go and you buy something and it's not actually the price on the price tag, it's a little bit more because of that tax. So this is our problem of the day, one of the ones that we'll do together. Ben wants to buy a baseball cap that costs $24.50. The state sales tax is 8%, or 8.08. How much will he pay in sales tax? So this problem is about buying something and how and the tax that's involved. What we're trying to find out is that sales tax. It's not the total, it's just that part of the price that we're going to increase and add on at the end. So this is something that we have had experience with. Last week you had a teacher assigned lesson that practiced finding the percent of a number. And I'm going to link how you do that with fractions to our new material, which is working with decimals as the factors. So the two numbers that are important that I'm going to focus on is the 24.50, the price, and the percentage as a decimal today. Okay, so I'm going to go on to the next slide and increase this a little bit so that you can so that I can write on it. And I apologize in advance for my pen, not using my pen from school because I'm at home, but we'll do the best we can. So when I'm thinking about this, first I want to estimate. And so I'm going to change my number of my price to 25, and I'm going to change my decimal of 800ths to 0 and 1/10. And that power of 10 is really easy for my brain to work with because it's just going to move that decimal point over one place. So I'm getting an estimate of $2.50. Now I'm going to actually think about what I knew from fractions and how can we write these decimals as fractions. And that's where I'm going to start. So I'm going to turn my pen on here. And this price, $24.50, I'm actually going to write that as a mixed number first for you. So we have 24, and I'm going to write it as 24 and 5/10 because I know that 0 is in the hundredths place, but I'm going to just use it the tenths place. And so I'm going to rewrite that now as an improper fraction. The 10 stays on the denominator, and we're going to have 24 times 10, which is 240, and then we add that 5. So I'm getting a numerator of 245. Now I'm going to write the other number, the 800ths, as a fraction, and the 8 is going to be in the numerator, and because that 8 is sitting in the hundredths place, my denominator is 100. All right, and now D and E is really in from page 90, talking about multiplying these two together, because we knew from our work with percents that when we're finding the percent of a number, we're multiplying. And so when we multiply, we are going to get a denominator. 10 times 100 is 1,000. And then when we multiply the numerators, 245 times 8, we get a larger number of 1,960. Just making sure I have the right numbers. So this is really our answer, however, it's in fraction form. So now we have to write that as a decimal. So if the denominator is in 1,000, we can, just like we did up here, we can simplify this, and it ends up being that the decimal point is going to be, instead of after the 0 in our numerator, it's going to be moved over 3 places because we're dividing by 1,000. And we can also check that on a calculator. So our decimal answer is 1 and 96 960 thousandths, or if there's a 0 at the end, we can just simply write this as 1 and 96, sorry about that, hundredths. So that is linking fractions to what I'm going to now show you from your instruction book, because this is a day 1. We're going to find out some more. And this is from your instruction book, page 91. So you multiply decimals in the same way you multiply whole numbers. So I showed you the fraction piece, and you can think about that fraction multiplication going on to help you make sense of where the decimal point should go. That's why I'm going to be focusing a little bit on fractions to get us started. So when we're multiplying decimal times decimal, it's the same process as what you did with whole numbers. However, we need to think about where is the decimal point going to be in the product, in the answer, when we get done. So you can think about the fraction multiplication to help you answer that question. Where does the decimal point go? I want you to focus on the denominators. 10 times 100 is 1,000. That tells you that you're going to need to have your answer be written into thousandths place. So tenths times hundreds is thousandths. You can see here a traditional setup of a multiplication problem using our numbers from before, from Ben's problem. And you can see this kind of hopping and counting the decimal places. And you can see that the 24 and 5/10 has 1 decimal place. And the other number, the other factor, 8 hundredths, has 2 decimal places. So you can have a little trick and add those decimal places up to know what place you should put the decimal point in your answer, in your product. And just like up here, when we got an answer of thousandths, we are getting 3 decimal places as how many places should be to the right of that decimal point in our answer. And it helps us put the decimal point into our product. The number of decimal places in the product equals the sum of the number of decimal places in the factors. So you can see 1 factor 1, second factor 2 decimal places, and so we have to add those to find out where do we put that decimal point. Could it be in making it 19 and 6/10? Should it be 196 as a whole number? Should it be 1,960? All of those questions could be answered by your estimate. We want an answer around $2.50. That also can help you with the decimal placement, but this is our trick that we're going to be referring to as we move forward. So let's try another one. And I'm going to, slide that up for the beginning of this. So 4 6th graders are working on a project. And they are going to paint a large banner and need to project the floor. Sorry, let me read that over again. They are going to paint a large banner and need to protect the floor. There we go. They measure the floor, which is 3 500 meters by 3 658 thousandths meters. How many square meters of plastic do they need to cover the entire floor? So we are talking about area, and that's not a new concept. We need to multiply length times width, okay? So we are going to need those 2 numbers, and we're going to be multiplying these 2 decimals. So before you try this, let me just explain the fraction piece. Actually, no, I'm reneging that. I want you to pause right now and try this, and then I will resume and tell you some of the thoughts around solving this. If you're not comfortable and you want to see one more before you try it, that's totally okay. You can just continue watching. But if you want, try it on your own and then resume. So we can think about fractions, again, to help us place our decimal points. And you can see that this was already one of the models in your instruction book, where you're doing the same thing I was with Ben's problem. You're writing this whole number as, or sorry, mixed number, and then converting it to an improper fraction. Doing the same thing with the second number or factor, and then multiplying those two. I really just want to focus on the denominator, and you'll notice that 100 times 1,000 is 100,000. That 100,000 means that the answer should have 100,000. That place value place should be how many decimal points, decimal places are to the right. So our answer at the end should read so that there is 5,690 100,000. So it's a complicated denominator to work with. So I know that fractions are not everyone's cup of tea, and so that's why we're going to focus on the traditional algorithm itself. And I just wanted to give you the background to why the decimal moving trick works. Okay, so we're going to be seeing a decimal in the 100,000ths when we're done because of those denominators. So we are going to multiply as we would with our whole numbers. And so I want to just remind you that everything I said in lesson 9 about line up those decimal points is only for adding and subtracting. Does not apply to multiplication. So you'll notice that I have slid the 3 and 5/100ths all the way over to the right. I did not line up the 3's and the decimal points. So you need to multiply just as you would with whole numbers. So you're ignoring the decimal points, and you're just making sure that right-hand side has the numbers slid all the way over so that it lines up. The 8 is over the 5. Now you can see in my red, I've hopped like we saw in our example and counted the literal decimal places in the first number, and I've counted 1, 2 decimal places in the second number. So that's going to help me know how many decimal places, 5, I'm going to add those numbers up, should be in my answer. So now I'm going to multiply like there's no decimal whatsoever. So like it's 3,658 multiplying by 305. So as a review, I'm just going to bring this up a little bit. Actually, let me just get rid of this. There we go. And so I can extend the page. So as a review, when you're multiplying traditional algorithm, you're going to start with this 5 and multiply each number that's on the top by that 5. So 8 times 5 is 40. You can see the 0 is already there written out and typed to try to save some time. Then I'm going to do 5 times 5, which is 25, plus 4 is 29. Notice I have the 9 there, and the 2 is important, so I'm writing that part in. The next thing I do is 5 times 6, which is 30, plus 2 is 32. That's supposed to be a 3, and the 2 is right there. And then my last multiplication at the top is 5 times 3, which is 15, plus 3 is 18. So you see that 18. So that's the first step. Second step, quick review. Because you're moving over to this 0, the first number that you write down after you multiply has to be directly above. I know some people like to maybe put an X here so that they don't mistakenly put this first digit in the wrong place. So quick review, that has to be lined up with the 0. And obviously, everything times 0 is 0. So we do need those 4 zeros to hold the place values because of this. And I'm going to switch my color. It does get a little tricky and complicated. So color helps. 3 times, and then we go each number and multiply for the last row. 3 times 8, and I'm going to cross out this 4 because that was for my first row, and 3 times 8 is 24, so I have a new carrying number, and the 4, again, goes right underneath the 3. It needs to be making sure it's in the right column so that when you add up your numbers at the end, you get the right answer. Moving on, 3 times 5 is 15, so I have to carry the 1. This 2 is old. And 3 times, 3 times 5 is 15, but I have to add that 2, so that's why you have a 7 down here, 17. Sorry about that. And then 3 times 6 is 18, plus 1 is 19. This 3 is old, so that's why you have the 9 here. 3 times 3 is 9, plus 1 is 10. So that's how you got these numbers down here. When we add them up, we will get a 0, a 9, 2 plus 4 is 6, 8 plus 7 is 15, and we have to carry that 1. 1 plus 1 is 2, plus 9 is 11. Carry the 1, 1 plus 0 is 1, and then we have a 1. So you can see my digits there's a lot of them. So we do not have an answer of 1,115,690. However, I do want to just bring up the fact that if you were doing fractions, 305 times 3,658 happens to be 1,115,690. And so this is where the link from fractions comes in. We now need to rewrite this as a decimal so that there are 5 decimal places to the right of the decimal point. So if I were to put it here, the decimal point, let me make it bold and big. If the decimal point was here, that's only 2 places. That's not enough. So that's not right. Let me make this smaller so I don't erase my numbers. So I need to start over on the right and count 1, 2, 3, 4, 5 decimal spots. So the decimal point is going to go right there. And I don't really need to count this 0, but I do need to count it when I'm figuring out where my decimal point should go. But when I'm reading this answer, I can say 11 and 1,569 10,000ths. Even though this number is in the 100,000ths, we can drop that 0 at the very, very end. But we do need it to figure out how many decimal spots should be to the right. We have 1, 2, 3, 4, 5 decimal spots. All right, so I know this is a lengthy process, so hang in with me. I want you to try some, and we have 2 more to do together. So Madeline studies honeybees. Every week she weighs the same honeybee hive. The first week the hive weighs 11 and 607,000 kilograms. Its weight increases about 204,000 kilograms every week. At this rate, how many kilograms will it increase in 7.5 weeks? So before you get this started, there are 3 numbers here. I want you to think about which numbers would you maybe need to multiply together. Because it says how many kilograms will it increase, it's not asking for a total. It's just asking for the growth. Okay? So we do not care how heavy this thing is in the beginning at the first week. All we care about is answering how much will it increase. So we have to have the rate of the increase being multiplied by the amount of time that's going by for it to grow. So in that case, we do not need the 11. I did not want you to do a whole bunch of work and realize at the end, oh, I used the wrong 2 numbers. So hopefully that was where your thinking was going. So go ahead and try to practice multiplying these two numbers together. Hit pause and resume when you're ready. So you can see that I have everything pretty much done with this problem except for the decimal point. So I counted decimal places in my first number and got 3. You can see that over there. And then 1. That means in my answer, I need 4 decimal places to the right of that decimal point. So if I were to place it between the 1 and the 5, that would be 4 decimal places. If I were to place it in between the 5 and the 3, that would be only 3 decimal places. If I put it here, it'd only be 2 decimal places, and here would be 1 decimal place. So I really want the first situation to be where that decimal point goes. So I'm getting 1 and 53 hundredths. When I read this answer, I don't have to worry about these zeros on the end. It does not change the value of that number at all. Hopefully you were successful in that traditional multiplication of essentially a 3-digit by 2-digit multiplication problem. The next one I am going to set up for you and then reveal the answer. Again, please try it first and then see if you're right. This one is actually a kind of a weird, grossed out kind of topic of how long would fingernails grow if you didn't cut them, they never broke, and you used that rate. So let's dive into this one, even though it's kind of a topic. Your fingernails grow at an average rate of 2.5 inches per year. Maybe you didn't know that. I didn't. If they grew at an average rate, you never cut them, and they did not break, how much would your fingernails grow in 4.5 years? Weird to think about. So you are multiplying the rate by the number of years to find out how long your fingernails would be at the end of those 4.5 years. Go ahead and try it, and I'm going to talk about it right after. So you can see that I have most of the multiplication done. 5 times 5, remember, we're starting at that 5 in the tens place. 5 times 5 is 25, and we're multiplying as if there were no decimals at all. 25, and then 2 times 5, 10, plus 2 is 12, carry the 1, and we have a 10 plus a 1 is 11. And then we take our 4, and again, we're lining it up underneath the 4. 4 times 5 is 20. It happens to be that I can use this 2 right here. 4 times 2 is 8. Plus 2 is 10. I can use this 1 right here. Put that 0 there. 4 times 2 is 8. Plus 1 is 9. So when I'm adding it all up, I do get a 10125. Now let's talk about those decimals. We're going to add our place values, 2 decimal places, plus 1 decimal place, and I'm always going to start from the left, and let me hide this, sorry. Start from the left and count 1, 2, 3 decimal points, and we are going to, have fingernails that are 10 inches long at the end of 4.5 years. Really weird to think about, but our real answer is 10 and 125 thousandths. So hopefully you were successful on that. That is the end of my explanations. You just have a quick question on Google Classroom to do no exit ticket with Pear Deck today. So I want to know from this video how and what you learned, how do you figure out where to put the decimal point? What was our trick? And in the product or an answer of a multiplication problem, when you have 2 numbers that are being multiplied together and both of them are decimals, so both factors have decimals, how do you figure out where to put that decimal point in the product? When you're done with that, you have some practice in your practice and problem solving pages 101 to 102. There are 4 questions, and I want you to make sure you're turning that in when it's done. But side note, because it is much easier to work on your whiteboard, you can see that I was actually doing that ahead of time. And you can just take a picture of your work like this and attach it and add media in Cami. It's a lot easier than typing it out. So if you want to do that, please take advantage of that this week, so that I know normally I would say, just show me, I'm in class, but I'm not. So that is your option to use your whiteboard this week. Click Add Media in Cami, and you can upload your picture through your file in your Chromebook, and it would be an easier way to show your work. Please don't forget your iReady path. Your quiz should have been done yesterday on adding and subtracting decimals, so hopefully you have 4 work days to get that 45 minutes in. Hope this video was helpful. I was trying to keep it under half an hour. I think I did that. And good luck on your practice. And I will give you that feedback on Google Classroom once you turn it in on your progress and understanding. Thank you so much, guys. Bye.